Today we are looking at finding the area of shapes, and we are going to use our one simple formula that we have for the area of a rectangle. Area equals length times width. So when I have a shape similar to this, obviously not drawn perfectly, it would need to be parallel lines and 90-degree angles, we can use our formula, length times width, to get area. If I have a triangle, if I have a circle, those have different formulas, and we cannot apply length times width. Similarly, if I have a shape like this, it is not a rectangle. However, if I cut the shape, and now I have two rectangles, I can apply my formula. I can do length times width and get the area. I can do length times width and get the area. And then think, how would I find the total area? Area plus area is going to provide me with the entire area of the shape. And so what we're really doing is finding and forcing rectangles to apply the formula that we know. Looking here at our first shape, we can quickly identify that we do not have a rectangle. However, we can use our rectangle formula to find the area. I'm simply going to divide this shape, and now I have one rectangle and I have two rectangles. What I want you to do now is pause the video and take a couple seconds to draw this shape, write down your measurements, and split the shape into two rectangles as I have here. If you have not paused and drawn that shape, please do that now. I'm going to continue with the lesson. So for my first, we'll go with the blue rectangle. We need our length and our width. So here's where we need to look at the shape and make sure we're using correct numbers. I have a 3, a 10, and a 7 all attached or near the sides of this blue rectangle. Looking, you can see that this 7 here is really for this entire side. This 3 is for this side, and the 10 is for this side. So if you trace them again, you can see the 7 stretches across blue and green. So I cannot use that. So to find the area, I'm going to do 3 times 10 equals 30. And please do the same on your paper. Now I want you to pause the video again and look at the green rectangle. What do you think are the dimensions of those sides for us to find the volume? The area. Make sure you've paused the video to think. So again, if we look, we have a 4, a 5, and a 7. And again, the 7 stretches blue and green, so we cannot use that. So I'm going to do 4 times 5 equals 20. And to round this out, we need to combine our two areas. Now again, think, how are we combining them? We are pushing them together. We are combining the spaces. We are adding the two to get an area of 50 square centimeters. So we split into rectangles, found the individual areas, and added them together. For this next shape, I want you to pause the video to copy down the shape, and I want you to split it into two rectangles and see if you can find the area of this shape. I'm going to start solving, so if you have not paused to solve on your own, please do that now. So the first thing I'm going to do is I'm going to split it into two shapes. There's two ways you can do this. You can cut it across here, or you can cut it across here. You can look to see if one is going to set you up better than the other for solving, but in the end, it will not impact your answer. So I'm going to split across here and create my blue rectangle and my green. So now looking at my green rectangle, I have a 4, a 3, a 9, and a 6 all in the area of it. Looking at the 6 first, I can see that's describing a side that's split into blue and green. So I'm definitely not using that. The 4 is describing this side here, which is part of the green, but is not the full length of this rectangle. Here the 3 is describing this full length of green, and 9 is describing this full length of green. So I'm going to do 9 times 3 equals 27. Now looking at the blue, we have a 6 that again is on a split side, blue and green. They can't be what we need. And 4 is not even for the blue rectangle. So we actually have unlabeled sides for this blue rectangle. If you did not notice this, I want you to pause now and think, how can we figure out the length of our missing sides? You're going to need to use the information in this shape, and you can mathematically figure out what the lengths of these sides should be. If you did not pause your video, please do so now, because I'm going to show you how to find the missing sides. So for this first side here, I'm going to look at the lines going parallel. Here I have a parallel line, and here I have a parallel line. So if we look, this 4 is taking up this portion of the shape. So this is 4, which means this space must be 5, which then applies to this part of the rectangle. So I have 5 centimeters. So if you struggle with that a little bit, I want you to now look at how am I going to figure out this portion of the rectangle, again using parallel lines. So go ahead and pause if you need a second. I'm going to start solving. So here we have a parallel line. Here it's obviously parallel. Here is parallel. And then this full length is parallel. Well, this portion is 3, which means this portion is 3. And if this whole side is 6, we have a 3 here as well. So to solve here, 3 times 5 equals 15. And then we combine our areas. And we get a total of 45 square centimeters. So again, we are splitting into rectangles, and sometimes we need to use parallel lines to find missing information. Looking at our last problem here, a little bit more complicated. I want you to take some time, copy the shape, make sure you have all the information, and then I want you to find the area of the shape. I'm going to begin solving now, so if you have not already paused your video, please do so. So there's a couple ways you could divide this. You could divide across here and here, or a straight line down here. Now, if I notice, I do have one missing side. I could take the time to figure it out, or I could also see, can I split this up where that missing side actually won't matter? So I'm going to divide my rectangle here, here, and my third one here. So I'm going to start with the blue. I can see I have a 15, a 10, and a 3. The 15 is describing this full length, which is splitting those two colors, whereas 10 is just the blue, 3 is just the blue. So I'm going to solve that. Now I will redo this problem and solve it with a different division of rectangles. So if you're looking at this and you didn't divide it the same way, follow along or even pause now and try it again this way, and then I will solve it the other way as well. Looking up top, again, I have a 7, a 3, and a 12. The 12 is describing the full length, which will not be useful. 7 times 3 equals 21. And then I have the green, which is full length here of 12. And then I have this portion here, which I don't know the length to yet. So I'll take my 12. So looking here, I can see that I have seven is for this portion, which would mean out of the 12 that this would have to be 5. I can also compare that to the bottom here. This portion is 10 out of 15, so it would have to be 5 again. So both directions, it points me to the same answer, so I'm confident in my work. I get 60, and now we add them up. $30 and 21, which gives us 111 meters squared. So just to show you the other way, I'll leave my answer up there. Let me erase real quick. If I were to divide this the other way, I'll go blue here, green here, and yellow here. Yellow, I have 12 and 3. Blue, I have 15 and 3. And then green, again, this 12 is not going to indicate because that's the full length. So I have a 12, and I have a 3 and a 3. So the 3 will be here and here, which means this is going to be a 6 left. And then again, we figured this other one out earlier. I have 10 here out of 15 total, so this is going to be 5. It's honestly why I solved it the other way, because you could see here I had to figure out 2 sides versus the other direction. It was technically only 1, but it wasn't too bad. So now I have 30 plus 45 plus 36 which again is going to give us 111 meters squared. So the key here really is our rule. Area of a rectangle. Use the information and knowledge you know about that and solve for rectangles.